Okay, so for beginning of this week's work, we're looking at Newton's second law. So we're beginning some review of some of our biggest topics for the entire year. And as a reminder, Newton's second law is really an equation that gives us a relationship between acceleration, the net force acting on an object, and some object's mass. And that's that the acceleration is equal to a net force divided by the mass of that object. And this was where we did things like we drew free body diagrams, and we know that our net force, we practiced calculating that as a difference, or sort of like the sum of all forces. But if we had one force going to the right and a force going to the left, this one going left would be negative. So when we add these two up, it's sort of like we would almost subtract them. Um, but today, what I really want us to focus on is sort of investigating in a more tangible way the relationship between an acceleration and net force. So linking these two things specifically. We'll be keeping the mass constant for this entire investigation. But you can think about, if analogies help you, acceleration as progress on some kind of issue, and net force being the effort put in to make change on that issue. So maybe, something has not been accelerating nearly as much as we would have wanted for years or decades or centuries. And so then the force that is required to make some certain acceleration happen or make some kind of change happen increases, and we realize that force might be needed to achieve the change that we desire. So when we come into this simulation, when you click that link that's in the work, it'll take you to this screen, and the default is net force, but we're actually going to come over to this acceleration tab, and I'll click that again, and we're in here. And it should look like this when you first get in. You do need to click basically all of these boxes. The speed one isn't totally necessary. You're not going to need to measure the speed, but if it's just an easier direction to say click all these boxes. I'm also going to leave this friction slider exactly where it is, so I'm not going to touch this slider at all. I'm going to leave this sort of fuzzy ground there. You'll remember when we did this in class back in December-ish or November, I usually turned the friction down to 0, in which case the ground got icy, but I'm just going to leave the friction right where it is for us now. And the default object is this 50 kilogram object. Now, the way that we adjust the amount of force that this mannequin person exerts on the box is with these arrows. So if I click these double arrows, it's going to make the force go up by 50 newtons each time, and if I click these small ones, that's how we adjust it, just by 1 full newton each time. So you'll have to make sure that you're exerting the right amount of force. First, I ask you to exert 100 newtons, then I ask you to exert 100 and I believe 44 newtons, but let me check this. Yep, 144, and then 194, and again, I can just go up sort of to that 50 point. And it'll be important for you to actually hit this play button once you do that, and then I can measure my accelerations as a result of any of this stuff. So you'll leave that same mass and just fill in the data. So the friction force, the reason that we had to click all of these boxes, let me reset for a second. The reason that we had to click all of those boxes because I want you to be able to analyze maybe how these friction forces change, and maybe remember how we calculate static versus kinetic or sliding friction, how we calculate these net forces, and then ultimately this acceleration. But those are given directly in this by, so for this friction force, that's given as this little red arrow, and it says over here it's next to the mannequin, but it's hard to see. So here it looks like it's 94 newtons, but this is for an applied force of 150, so that's not one that neatly fits into any of these boxes. But then the net force, that's what in the simulation they're calling the sum of forces. So this little green arrow is going to give you the net force, and then the acceleration is given right here, and it looks like it's 1.12 meters per second squared. And so I would just want to make sure that I get that for each sort of rung of that table. And then to sort of make it easier for you to analyze your data, I have a graph of net force versus acceleration, so progress on some issue related to the force exerted to make change. And the absolute last thing that you need to do to wrap up this explanation is basically how would you explain the relationship that you found in the table or in this graph if you had to explain to like a younger kid. So put it in as simple terms as you can. I think that's a good exercise and just a good way for you to practice and make sure that you really understand this relationship and this really important material from earlier in the year.